Hello, everyone. Welcome to this week's episode of ClueCon Weekly. Joining us this week is Giles Heron, which is a principal engineer at Cisco Systems and is based in London. He's an expert on containers, high performance, and he has over 30 years of experience with software network architectures, inventor of a few things, chairman of an IETF working group, and mainly for joining us today as the inventor and originator of the media streaming mesh open source project, which I want to hear everything about. Thank you for joining us, Giles.
Thanks, Luca. Good to do this. It's a new experience for me doing a session like this online. I guess I speak at various conferences and things. And in fact, what I'm giving you today is probably a bit of a preview of a keynote speech that I'll be doing at CubeCon in Europe. So that's in Amsterdam, which I think is something like the 17th to the 21st of April. I think I'm doing mine on the Friday morning, the 21st. So I guess the question is why would they ask me to speak? And I think there's an interesting dynamic really with cloud native, which is that it really originated very much in the world of web applications. And Kubernetes, I guess, was originally a Google thing. And so I suppose the challenge becomes, well, this infrastructure is great for deploying web applications, but what happens when you want to deploy other things? And so that's where I decided to take a look at that as this project. And so we've been running it for a while. It's in open source. At the moment, it's really me, and I've got a couple of developers helping me out, but we're really looking to get more community involvement with this. And as I say, I'll give you a quick overview in terms of why we're doing it. Well, our goal was to say, well, we know that Kubernetes is great at web applications. Now, think about web applications, where do they fit in the world? And I guess management consultants, people who do MBAs, etc., they love these kind of 2x2 matrices. And so if you have real time and non-real time in one dimension and interactive or streaming in another, my contention with that web apps are very much the non-real time interactive applications. And so really with media streaming mesh, we're trying to look at that opposite corner of how do we handle real-time live streaming applications. And so of course the canonical example of that, I skipped forward, would be live media. And so in this project we've decided to focus on anything that runs over RTP. But what we've decided to do is to split the data plane and control plane such that we can swap in different control planes. So that could be SIP, it could be RTSP, it could be RIST, anything that is involved with RTP media. And of course, WebRTC for these sort of live conferences. So when we came to looking at that initially and saying, well, how would we do this in Kubernetes? I guess I realized quite quickly that the normal Kubernetes networking, which is NAT-based, wasn't really going to suit us. Now, I'm a network engineer by background, and so NAT tends to be a bit of a dirty word for me. And so when I looked at Kubernetes networking, that was really where it was coming from, was NAT. And so kubeproxy is just address translation. Node port is how you could expose those kubeproxy services externally. And what you find is it works great within the cluster. I'm sure there isn't meant to be timing on this deck, so this is going to go horribly wrong. But it doesn't really work outside the cluster because you end up using high port numbers, which aren't great. But where it really goes wrong is when you try to address real-time media. And I guess there are a couple of challenges there. One is that you typically have a TCP control plane over which you negotiate the UDP ports you're going to use for RTP. And of course, the NAT can't see that negotiation. The other problem is people often use multicast, and multicast doesn't really play very well with most of the Kubernetes CNIs. Those are the container networking interfaces we use. So service meshes have got a lot of news in Kubernetes, and using load balancers to expose externally. That's great for TCP apps. It's super great for HTTP because you can go in and do all the layer 7 stuff and say /customers goes this way, /products goes that way, all that stuff. But then kind of fails in that it doesn't support UDP today typically, and again, the real-time media is going to be a problem. What I've seen some people do is to literally just use host networking Kubernetes and bypass all of this. And that works great, but the challenge is you end up just having one media pod on each node because you can only expose each port once. So really that's where we came from, saying let's focus on that real-time piece, but let's maybe have some coverage at the lower layers that we encapsulate over those. So that's really a very brief overview of why we did it. In terms of how we did it, I guess, like all these things, you iterate and you come up with different approaches. And I think where we've ended up is saying, well, let's try and have a control plane per cluster, whichever control plane that might be, but let's have a shared infrastructure to run those control planes on. Let's have a proxy on each node that we run in Kubernetes, that's a daemon set. So you run one instance on each node, and we run that in the host namespace. But then let's have pods with the actual media apps in, and use proxies to, effectively, the RCP proxy gives us that fan out of the data plane through the network. And we have these little stubs that sit alongside the apps that handle basically talking to the control plane and redundancy and that kind of stuff. Straightforward architecture and very much aimed at what Kubernetes does in terms of how it builds things. But I guess our longer term view is we'd like to make really RTP streams themselves almost first class citizens in Kubernetes. And so I'm looking at some approaches there. Perhaps we can have those almost defined in Kubernetes as entities. And so you could just, for example, have a proxy where instead of plugging functionality into it, you could imagine building a pipeline where each application literally just receives a stream and forwards it. So really, in terms of where we're trying to get to in benefits, we're trying to do all the kind of observability and security that people in the service mesh world have, but we want something that has a much lower footprint, that doesn't introduce latency and jitter. And of course, in terms of observability, that's the kind of stuff we want to measure. And we want to have something very redundant that recovers smoothly from failures and that kind of thing. So we have a demo, which I'll probably show you in a bit, but let's come out of this and then we can perhaps, I was hoping I could actually just hide that again, but that didn't seem to work. But yeah, maybe we can just have a chat and talk through some of your thoughts on media and where that lives in the cloud world, and just have more of a discussion. But I guess that gives us at least a kind of, this is where I'm trying to go. Feel free to tell me if you think I'm nuts.
No. First of all, it's very interesting. It's by itself working with media applications in containers, being Docker or Kubernetes, has always been a challenge. I come from a high performance background, but I almost immediately started telephony after that. I've been in telephony for a long time now, and for a very long time, everybody was saying you should not run, whether it's FreeSwitch, Asterisk, or any of the telephony open source platforms on containers, because that will give you problems with the timers, and the networking wasn't great, and all of it was not exactly good to run. And for a while, it was actually true. Then for a long time, it wasn't true, but people didn't know, or rather kept thinking they could just keep going that direction. So anything that's native to the cloud is going to be useful. In fact, I think we're going to need more of these projects to make things, because right now, going back to my telephony background, any server you run is usually a monolith that doesn't cluster in any way, other than thank you.
Yeah, no, I think that's a fair comment. And I guess the challenge with that monolith thing is people talk about refactoring apps into microservices in order to deploy them into the cloud. And I guess that's the challenge, is does that happen? And if it does happen, does that give us an opportunity to move away from perhaps more legacy interfaces that we've defined for monoliths to something more cloud native? And we see that with web apps, where perhaps people are looking at, can you move away from HTTP, HTTPS to using gRPC if you're rebuilding the app anyway? So it'd be interesting to see your perspective on that. Do you see those kind of protocols like SIP as being things we maintain forever, or do you see newer protocols as an option?
So what are these for people who are maybe less technically inclined? What will be a few use cases for the media streaming mesh? I can write one, which is very easy, which is just broadcasting.
Yes. So I think there are a bunch of use cases in the broadcast arena. I think there could be some around contribution video. So if you think about, I've talked about real time, and I think the question's always how real time is real time. And I'm a Paul fan, and we've all had that experience where you're watching a match, you're watching on a streaming platform, and your friend's watching on cable or satellite, and he texts you to say, wasn't that a great goal? And you're like, well, I haven't seen the goal yet. And so, we know that on the internet, a lot of that stuff today, it's all delivered with HLS and Dash, and those sort of technologies that do introduce some buffering. And I know there are one or two organizations out there looking at, being able to do WebRTC through CDNs. But yeah, I think that distribution piece to the final consumer is clearly there. If modular getting around all the protocol soup of how you get stuff through firewalls, etc. But then the other piece is that more front end piece of how do you bring in video feeds, and historically, in broadcasting, people have used things like what was analog in the beginning, and then things moved to SDI, which is a sort of standardized digital interface that is used for video, but isn't IP based. And of course, what we've seen as IP people is, every industry in the end has succumbed to the tsunami of IP. So just as telephony moved over to SIP, in the end, the broadcasting world's going to end up moving to IP. And so I think there are use cases there where you're perhaps bringing the feed of whatever the football match is into the stadium. You've got different cloud workloads doing things like adding that little strip at the top of the score, maybe putting little things at the bottom, maybe you're adding subtitles. But then you have the next piece, which is the distribution of how do you take those streams and push them out, either to antenna or cable head ends or to CDN caches. And so that first piece today in terms of protocols tends to be, as I understand it, ST2110 is the protocol people tend to use. It's very high bandwidth, uncompressed video. Typically, I think it's something like 12 gigabits per second for 4K. And that, again, squares with what you said earlier about, the challenges around timing, etc. Because that is the question: is how well will those things work in a Kubernetes world? So I'm doing some work with some partners there, looking at things like move to a zero copy model, so that we don't have to send everything sort of through the default CNI and copy packets around every time we go from one container to another. But can we do it zero copy? I think next on that distribution stage, that's where RIST is the sort of RTP based protocol for that. There are some other, I think SDP is out there, but that's not RTP based. And in that space, I get like forward error correction, being able to send stuff over diverse paths, those kind of things become important. So again, those are use cases we'd want to look at. And really there, I guess it's about media streaming meshes and infrastructure, taking care of those concerns so that in deploying the app, you don't have to write your own code to mirror stuff over two paths. You would just tell the infrastructure, I want this sent over two paths, and the infrastructure would take care of that. And then, as I say, that final delivery to the customer, but that, the viewer, but then, as I say, that the challenge there tends to be around software at the very edge. So my TV may never get an update in its lifetime. Who knows? Depends a bit on the manufacturer. Even with my iPhone, there still might be issues if I'm sitting at home and I'm behind a NAT. But I think some of those things will come. And I don't know if you've seen, there's some interesting work in the IETF on something called media over QUIC. So they're looking at how can you use QUIC, so the same underlying protocol for HTTP3, how can you use that for media? And the great thing with QUIC is it is UDP based, not TCP. And there's all sorts of debates in that group at the moment of, do we always have the HTTP layer? Do we always map stuff into streams, or do we sometimes use datagrams? So I think that's very much a watch this space. And I feel like that's what hopefully will get us to having real time all the way to the consumer. Because I guess my contention would be that we know this real time stuff works over the internet, right? Or we wouldn't be doing it now. So why is it when I watch the football that I end up being 30 seconds or a minute behind? And it must be about the need to drive costs down, the fact that what CDNs today support is kind of pull mode with HTTP, so they can optimize their caching. Well, media streaming meshes and infrastructure, if you're delivering real time, the cache handles fan out for you. Sorry, the proxy handles the fan out for you. So you still get that effectively the same behavior as caching. So you would only be sending, one stream from the source to, say, a proxy near me in London. That proxy could then fan out to everybody who was watching. So I think the same kind of things could apply. And so technically, I think we could do that and drive the cost down. It's then a question of how we organizationally and in terms of, people who deploy CDNs, et cetera, how we get there from here. But I think there's also a ton of use cases around things like, even security cameras. Our big annual customer conference, the US flavor of it tends to happen in Las Vegas. And if you've ever been to a casino, you'll know that you are being watched from every conceivable angle. And yes, I get the civil liberties concerns, but you've kind of signed up for that if you go into a casino. And at the other extreme, you see, coffee shops, takeout places, somewhere I can go and get sushi here in London. Literally, I'll pick it up from the shelf and I go to a touchscreen kiosk with a camera and the rest, and there is no human involved. So I have to assume there's some kind of machine learning sitting behind that, saying, okay, is this person paying for the same number of items he bought? And that, again, is the sort of use case where you might want to always be saving the video feed. You might also want to always be passing it into an ML app, but you might only, based on some kind of alert that the ML sees something unexpected, only then do you want to show the video feed to a human. Because the issue is that humans are pretty expensive, but these days cameras are incredibly cheap, as is the ML processing. So I think we're going to be in a world where for every camera that's out there, or rather for every human that's watching cameras, there are going to be hundreds of cameras out there, which, yes, it's a little dystopian. So perhaps I shouldn't be helping enable that. But I think then there are other use cases, as I say, literally in what we're doing now, that things like WebRTC or the other equivalents, the WebExes and Zooms of this world, they could benefit from this approach too, I think.
Yeah, there's plenty to work around in the not just only the strictly container space. And I think we haven't been doing enough with pure RTP. Another project that has a lot of this kind of manipulation is Janus. And I've seen Janus used to do very interesting stuff. Only Janus is born of a monolith paradigm again. So you cannot really cluster Janus. It's just one.
Okay.
You have one process. If you want 10 of them, there will be 10 of them. And then you have to find a way to build balance or whatever, which is completely different from having something that is capable of being fully connected to each other. What's the what language or languages is the tool written in?
So it's a mixture. So the control plane is all written in Golang. That's really because that tends to be the sort of Kubernetes native language, just sort of almost historically, but it seems to work pretty well for that. In terms of data plane, our RTP proxy, the current one, which is kind of a prototype, is written in Golang. Some of the partners I'm working with are looking to write C and C++ based data planes to do some of this zero copy type stuff. And in terms of my own plans, I think my next stage data plane will be written in Rust. What I've done, I mentioned the stub earlier, the little stub proxy or stub sidecar that we have in each pod. That really has two roles. One is to terminate the TCP connection from the control plane connection from the client. And the benefit of that is that then if you have like control plane failovers, because that little pod that has shared fate, so my stub shares fate with the app, but it doesn't share fate with the control plane. So then it makes things like switchover much easier. We've all, those of us in the networking world, the good old days of trying to make BGP routers run nonstop. That was always the problem, was that, mirroring TCP session state and that kind of stuff. So I wanted to avoid that for redundancy. The other thing the stub does though is any kind of adaptation we need to do. So as an example, the current RTSP demo that we have interworks between interleaved mode RTSP, where the RTP packets are kind of tunneled in TCP, and it interworks that to regular RTSP with RTP and RTCP sockets. And so I wrote that one in Rust using Tokyo. If you've looked at Rust at all, there's a really good asynchronous ecosystem around Tokyo, using Tonic for gRPC, if I'm remembering all this right. And that's about 1,000 lines of Rust. But to be honest, a lot of that's because of this interleaved data thing with RTSP. So it's not big. And so I think for a very simple RTP proxy written in Rust, it's going to be less than that. So I'll probably do that next. And I think I sort of alluded to it earlier, I'm to some extent sort of tossing up between writing a proxy that has plugins where the goal, so really what this comes down to take a slight detour, open source, and again, be really interested in your views on this, but my sort of not great open source expert view of open source is that the hard thing in open source is getting other people to participate in your project. And I saw an amazing talk. I actually saw it live, but it's still up there on the internet. A guy called Jeremy Ruston, who I worked with in a couple of places, but the second time around was at British Telecom. And he did open source stuff like TiddlyWiki. He was the original TiddlyWiki guy. And he did a talk for us about open source. And the one real message I took away from that is make it easy for people to contribute. Like have plugins or skins or filters or whatever it is, something that people could contribute without having to touch your core code. And so really where I want to get to is that the control plane would be sort of plugin based. So we would provide that infrastructure for the control plane, plug in, whether it's RTSP or SIP or RIST or WebRTC. And of course, even those plugins hopefully will use existing libraries. So we've leveraged Go RTSP lib for RTSP, and of course there are things like Pion for WebRTC and so on. But on the data plane side, one potential approach would be to have plugins in the proxy. So have a Rust-based proxy, but with plugins, and probably have the plugins be WASM-based, and have a really simple, so you have a WASM runtime in there, have a really simple interface to the plugin where you just receive some packets and send some packets. But as I said, I'm kind of tossing up that approach against an approach of saying, keep the proxy super, super simple. And if you want to build a pipeline, then just simply sort of chain one hop to the next hop. But as I also alluded to earlier, I think if we want to do that, the clean way to do it will be to make RTP streams themselves kind of first-class citizens. Because at the moment, if I chain things together, what I typically do is I pull some data in, stick it in a server container running in my pod, and then I pull it from the next stage, because we're always in Kubernetes, and this is where scaling and Kubernetes being around web apps. The Kubernetes scaling model is that you have a service and then you have a bunch of replicas for that service and you connect to that service. And the problem is with real-time media that we're trying to invert it and say, what we really, the service to us really is a stream, and the stream gets fanned out through proxies. And so I think if we can almost have those streams as first-class citizens, then that would make it easy to build those kind of pipelines. And that would speak to your thing earlier about Janice and how you scale it, because I feel like the way you scale media, and it depends a bit on what you're doing, but often for things like broadcast where it's point to multi-point, scaling it really is about scaling out the proxy layer, not about having multiple replicas, because there is only one source. Now, of course, for telephony, that's going to, or even conferencing, that's going to be different. But you still have some of that aspect that you want to be able to fan things out. So, a typical, you're at work and you're on one of these WebEx calls, there might be 10 or 20 of you on the call. And so there is a degree of that fan out happening. So yeah, that's really where I'm trying to get to with it. And I think the other really important thing, of course, is that I think one of the things about real-time media, of course, is that the value of media is sort of directly proportional to the distance. If you lived around the corner from me and we weren't recording this for people to view, we'd probably be having this conversation in the cafe or the pub. And apart from during COVID, when none of us could leave the house anyway, the value is in communication at a distance. And I guess what I'm saying by that is what happens inside within a cloud provider is actually probably rather less interesting to us than how we get traffic from that location to the real users, be they humans, be they cameras or whatever, that are widely distributed. And so it probably drives a slightly different way of thinking than you would have for most cloud applications.
So I can tell you what we did with FreeSwitch, which is the closest example I have. And FreeSwitch was purposefully built almost entirely on a modular approach, to the point where you can start a FreeSwitch server that will do nothing. Because if you unload all protocols, you unload all control mechanisms, you can only control C it. You have to actually kill it from outside if you really unloaded everything, because it no longer has a way to accept any signal or any command. So that's how modular it is. It's fostered a lot of good contributions by the community. We have plenty of modules which are in the top 10 that are not part of the core team, so to speak. There's mod JavaScript that's been used, that's been contributed. It's like the #1 programming languages with Fuzzwitch right now, aside from Lua, which is sort of the built-in scripting language. And there's a couple codecs that were contributed that are super good. There's a few wrappers around mod AV and all the other stuff that are contributed. So I think from our point of view, the modular approach has worked both on the code structure standpoint. You can build a server that only has what you need, and on the community standpoint, because I feel like it's probably less daunting for someone to build from. I'm thinking about my own experience. I ran a Ruby telephony framework open source project for a long time. And from my standpoint, the idea of downloading the entire thing and patching something, if I'm not a super good programmer, can be daunting. While if I know it's my little folder, I maybe I even get a comment that will generate a skeleton for me, like some kind of make task that will give me an empty folder with a hello world plugin. Then I know that whatever I do, it's going to, and maybe I can do something that only works for myself. I publish it as is, and then someone else finds this and says, well, I need this, but it also needed to do these other 3 things. I'll contribute them. And then that's how it almost starts its own sub-project. That has worked for us very well. That is the, so yeah, definitely modular.
Yeah, exactly. And I think, my own experience when I looked at contributing a while back, I don't know if you may have come across it. There's a project out of Google for Games called Quilkin, which is kind of a UDP proxy aimed at gaming. And I added sort of a hash-based load balancer to that. That was reasonably straightforward because I didn't need to go too deep into the code. But then when I tried to add in a feature where I could kind of APIs to decide where to send the stream, at that point, I quickly discovered I was kind of doing open heart surgery with a chainsaw. And it's not, and that may be that I was trying to make it do stuff it wasn't intended to do. But I guess that's where that really started me thinking about this issue of how do I make it easier to contribute? And yeah, anything modular has to be the way forward. And whether that's, let's say, whether it's control plane or data plane plugins, for sure we want that. And obviously, I'm not going to contribute personally. I'm not going to write something like congestion control. That's not something I'm an expert in. But if we can make it easy enough for someone to plug that in, then maybe somebody does contribute that.
Yeah, the idea is that's another thing that we've all had projects where we needed something we couldn't do as the originators, right? And that will probably be a good way to start. Like, why not just have people help? Like, hey guys, I need someone to help with this thing. And then you go back to the good old mailing lists of old, which is still going. Like, so many projects still have mailing lists. Till recently, I met someone. I think we had someone on the so GStreamer. Yeah, the GStreamer project is the Swiss Army knife of video media, whatever. And we had the project lead on ClueCon Weekly a few weeks ago, and he was saying that the main thing about it is how complicated it is to maintain the whole thing from scratch. There's a lot that you can do with that kind of approach. I don't even know if it's the right approach. They're still running on IRC, so there's only mailing lists. They still have the IRC. Freenode went away. I didn't even know. I'm ashamed to find out that Freenode was gone. I didn't know because I'll be honest.
I didn't.
Haven't used IRC in a while, and I used to live on Freenode. That probably puts an age on us. So we shouldn't say that too loud, but it's.
And it probably puts an age on a project as well. If you look at what the project's using, I found it weird because my background is I was a programmer in the beginning, back in the early 90s, writing C code for networking, and then I moved into kind of network design, network architecture kind of roles, very much around the commercial internet boom of the mid 90s, and stayed in that space. And then when I started doing this project, it's kind of, in fact, even before this, when I was working on helping out on Open Daylight, which is an SDN controller. And I suddenly discovered this whole new world of things like Git and Maven, all these tools that I'd never seen before, and just a different way of doing things. And it's been interesting, though, even in organizations like the IETF, we're now seeing much more stuff turning up on GitHub. In the old days, we used to write our drafts using things like nroff, if you remember nroff. and now they're all being done on GitHub, and it's being done as, and there's a kind of coming together there of open source and standards, which is really quite nice as well. And yeah, so I think for this project, I'm trying to be in that kind of GitHub, Slack kind of world.
Yeah. Oh
You know,
well,
that's where people are now.
the modern world, from Subversion and IRC to Git to
Yeah, yeah,
GitHub, and which in its own GitHub is almost its own flavor of Git. It is Git, but
right.
it's also other things. So it is. It's
Yeah.
very interesting how we went from. But your project is old if you had a Usenet group named after the project. That's where that's
Exactly.
where I draw the line. Like if your project had
Yes.
a Usenet group named after it, later became Google Groups. I think I don't even. So I one day I need to sit when I have half an hour. I need to sit down and figure out how Google ended up owning the entire Usenet, I guess, or they just
Hmm.
transferred for free. I don't know, but for a long time, Usenet was Google, right?
Right, right. I mean, it's funny, yeah, because I remember building an ISP in the mid-90s, and those, in terms of the big things we were providing as infrastructure, it was pretty much mail and news. That was what,
Yeah.
and I used to annoy my colleagues by saying the network was the only bit that really mattered. And of course, that is the world we've moved into now, where it's just, internet providers just provide access. Usenet's disappeared, and you get your email from whoever. But yeah, we were definitely dating ourselves at this point. We should probably stop. I might start doing imitations of a V34 modem if you don't stop me.
Well, going down that route, the last remark I want to make is: do you remember how to run an email server? Because I don't. I was helping a customer getting started, and as an offhand remark, one of their engineers on the call said,
Mhm.
"Well, if we move the domain here and there, they were figuring out how to slice up their domain names so they could
Mhm.
give subdomains to their Kubernetes cluster, actually. And well, if we
Right.
move this domain, then we don't have email access anymore." And the guy just goes,
Oh well.
the engineer just goes up and says, "No, I'm not going to run an email server. You guys find out something else. You go buy whatever email server you want. I will never run an email server for you." It's like 10 parts. It's like 10 moving parts. I looked it up, and it's like you need a cluster to run an email server these days because
Yeah.
everything is its own little
Embarrassingly,
thing.
yeah, it's embarrassing. I do still run my mail server, and I should probably stop
I don't know if you know how to do it more. You're good. You're better than I am. I have to say, even if we all started out working in ISPs in some way, right? It's literally how
Yes,
we
yes,
during university.
completely.
I was working in ISP just to get some extra money for mostly video
Yeah,
games,
yeah,
and
right.
and I remember them setting up all the sort of weird things like running the email servers, and we've got to set up the anti-spam thing. At the time, spam cops and that kind of stuff were new, and so it was just all incredible, and
Oh yeah,
it's so weird. Now everything is so commoditized. It's just
yeah, yeah, yeah. And in
well, it's
those
a
days, it
better
was things
word.
like, yeah, scaling your mail server beyond 32,000 users, and that was a problem. And all those old days where things, the default was generally to use Unix user IDs for everything. And we were building an ISP. This is back in about 95, 96, and we were trying not to do that because we had this dream that it would scale beyond that number of users where we'd hit those
I was
problems.
working at an ISP around 98 to 99, so we're
Yeah,
almost contemporary in that
yeah,
regard.
yeah,
Yeah,
yeah. As I say,
the
happy days, but
ISDN lines and
oh yeah,
bundling
oh yeah.
channels, and yeah, the good old days of not having a phone line when you're downloading something.
Right, right. But the thing is, it all just does work now, right? And somebody I was speaking to said he was on a flight where there was Wi-Fi. And this was a good few years ago now, and he was Skyping his wife, and she was saying, "Wow, that's amazing!" And then she showed the iPad with the Skype call to her kids, and her kids were like, "Yeah, and why wouldn't you have Wi-Fi on a plane?" To their world, the world of that generation is an always connected, always on world. Whereas to me, I still get excited. I was on London Underground recently, and they have 5G in some of the tunnels now, and I was like, "Woohoo!" But why? Yeah, why wouldn't there be? Ubiquity is its own reward, really, and that's what we see now. And to come back to media streaming mesh, it's like, well, this connectivity is ubiquitous, and we know we can do this. So why isn't everything real time, really real time? And let's get that fixed.
Yeah, there's so much. Well, Last remark on 5G, which you brought up. The problem with the 5G right now is I just was at MWC, the Mobile World
Oh yeah,
Conference in Barcelona, and the overwhelming feeling so far is that Ericsson and a couple other equipment manufacturers played the role of the casino owners. Like they made bank on selling 5G equipment, and now the carriers have to find a way to monetize, which is what we're working on. And this ties back to the startup presentation because honestly, I feel like one of the best ways to monetize 5G, which the edge capabilities, is moving mesh nodes for distribution to the very edge, giving you incredibly good latency because those nodes are on huge backhauls, right? Tens of gigabits of backhaul, and that the latency is negligible. Most of the latency is
yeah,
acquired in the last mile. So if we could have something like the media streaming mesh node on a 5G edge server, which has 20 milliseconds of latency towards the final device, you can achieve. I mean, it's almost
yeah,
real time.
yeah,
Like we're talking light speed transmission. Like
yeah,
we're
yeah, yeah, yeah.
approaching the minimum. It's
Completely. And the only thing I'd say to slightly counter that is this thing of, in the end, it's speed of light that's the killer, isn't it? And of course, the great thing living here in the UK
physics.
is we're not very big in terms of speed of light here, but your experience may vary if you're in rural Australia.
Yeah, but still, if you can move stuff as close as you can to
Yeah, for sure.
80% of the world's population, you can make things incredibly snappy. And I think we haven't seen. So I've done some experimentation, which I mean, one day we might just sit down and try it. I have a full setup to
Yep.
test for on 5G edge stuff. We did some experimentation with streaming audio from a device to a speech recognition engine that was super simple, which is keyword detection. I didn't have time to run anything more complicated, so I was looking for a single word like Alexa, do this, right? And going back, so doing some little processing on a node and sending it back on the edge. I had 90% less latency than compared going up to the cloud. So there is something there that needs to be looked at because really, and it might be even better for ingestion than it might be for distribution. Like if you're generating audio and you're sending it to an edge node, which then has a huge backhaul and doesn't suffer from any of the issues that our common internet lines have, there's something there. So we will look into it and we can maybe discuss this further.
Yeah, well, maybe we'll end up working together.
Cool.
That's the great thing with open source. It opens all that up.
Absolutely. Well, so we're approaching the end of the episode. So thank you for joining us.
Hey, no problem at all. Really interesting, and I'll certainly be. I'll be thinking after this. You've given me some thoughts, so that's always great.
Absolutely. And we'll put all the links for the project and Giles' profile on the video comments. And just for everybody else. First of all, thank you, Giles Heron from Cisco, for joining us today to talk about this media streaming mesh open source project. And for everybody else, I'll see you next week. Goodbye.